Hello everyone, my name is Nyanta and my student ID is 301224927. So let's get started with our assignment exercise question number 1, which is classmate search. So here the graph that illustrates the relationship among the students in your class, and here you have to replace you by the first name. So you has a connection with Adam, with Frank and with George. Similarly, Emma has a connection with Bob, with Dolly and with Adam. So we have to create this connection in the coding section. So let's quickly move into that. So here in the graph.py file, I have created the connections. So my name is Nyanta. So Nyanta has a connection with George, Frank and Adam. Emma has a connection with Dolly, Adam and Bob. Similarly, using the diagram, we have created this connections. So let's move to the next file, which is state.py. Here we have an initial function, initial.state method, where I have passed my name as an initial state, and Dolly as a goal state, because I have to create the connection between the Dolly and me. So in the next is Q BFS. In this file, I have made several changes. First of all is that I import connections from graph. I have import all this connection in QBFS file using import function. So here I ask from the user to enter the name, and if it is in the connection list, further it will ask for the student name to whom you want to create the connection. Otherwise it will show that please provide a valid argument. So this is the condition. So we have to now one more thing, we have to create a BFS function, BFS dot first name, so Nyanta, and we have to pass the three arguments, that is the connection or the data where we have stored the information, the start name and the end name, or the final name or the goal name, sorry, initial name and the goal name. So here the function method is called by using connection. I have passed the initial name and final name. So let's quickly get run this program. So it asks for enter your name. So let's just enter my name. So I have to create the connection between me and Dolly. So here the connection is created between me and Dolly, and the path is generated, and the shortest path is generated is by Nyanta, Adam, Emmy and Dolly. Now the second question is, let's quickly move to the second question. So the second question is that basically we have to differentiate between greedy, A star and UCS algorithm. So we can choose any of the one, either greedy or A star, and we have to convert it into the UCS algorithm, and we have to write a short analysis on this. So let's get started with our coding section part. So I quickly close all these tabs and open my second exercise code. Hmm, so here is my second exercise code. I'll just quickly, yeah, here it is, my second exercise code. In this we have to do some minor changes, as what we need to do is we have to convert A star into the UCS algorithm. So in A star we have to convert both heuristic function as well as coast path, that is HN as well as GN. But in case of UCS, we only need to convert path coast, that is only the GN function. So to convert the A star into the UCS, what we need to do is to just remove that part, heuristic part from the coding. So we get our UCS. So here what I did is that I only take distance from the goal node, that is the GN function, and I remove the HN function from it, so that I can convert it into the UCS. So let's just quickly run this program. So here a graph is created. So here it is, a graph is created for the UCS. So this is our second question, and we have to write the short analysis on this. So let's quickly, yeah, here in the written response, I have written the short analysis, why we choose and which algorithm is choose. So according to me, A star is perfect because we have to calculate both heuristic as well as GN function. And in case of the A star, the it provide the optimal solution, as well as the cost of solving the problem is equal to or more than the actual cost. So let's get move to the third question. So here in this question, we have a 8 puzzle problem in which we have given the initial state as well as the final state. So what we have to do is we have to first of all complete all the levels to reach to the final state. Secondly, we have two more problems. So let's just solve the first one. So for the first one, just a minute. Yeah, here for the first one, I have created this. So in this, we have the initial state. So what we can do is we have the three possibilities. And one more thing, we have to move one element, only one element at the same time. So here I have moved 7 here, and here I have moved 6 downward. Here I have moved 5 here. So in this we have to calculate the Fn. Fn is what? Gn plus Hn. So 5 plus 1 is 6, 3 plus 1 is 4, 5 plus 1 is 6. So in the A star algorithm, what we need to do is we have to look for the Fn which is very less, or which is minimum, so that the function cost is reduced. So in this case we have a fn 4. So let's go with that. So here further we divided, we just move all the possible cases, we again calculate the fn. So in this case we get the fn 5, 5, 6. So these both have the same fn, so we further divide this, and for this we reached to the state but we didn't get any final state. So in this case the fn is 5 and 7, so we further go with the 5. And again this is divided into the two possibilities, and here we get our goal state. So this is, I guess, the best way to reduce the cost and to reduce the unwanted nodes, which cost much higher. So let's move to further. What are the other two parts? If this is a good heuristic problem for you, and suggest another heuristic, explain why you think is a good heuristic. Okay, so let me just go what I have written. So according to me, it is a very good heuristic problem because we have to calculate both GN and HN. That is goal cost and heuristic cost. And for this, we have to get the optimal solution, as well as it will avoid expanding to the nodes that are expensive. So in my opinion, it is the best way. So in this, what we have to do is we have to get HN is here, the tiles which are at the wrong position. So another way is that we can sum up the tiles. We can diagonally look at the tiles and place them in the correct order. So this all are assignment question. I hope you liked my video. Thank you so much.